Namaste everyone. Today in this video I'm going to show how to make a straight line fit best fit of the data given. I'm using VirtualBox Ubuntu operating system in VirtualBox and I'm just performing my operations over there. I've discussed here two methods separately. First of all, I will start with my first method. We start the terminal. Just enter the desktop, then make a directory named fit, then go to the directory named fit and then create a file data dot txt. Now we start inserting our data. One one 3 2 4 4 6 4 8 5 8 5 9 and 7 11 and 8. These are our data. The first column represents the values for x and the second column represents the value for y. We just save the file. Again, we go to the terminal and create a file named plot.txt. Now we type in the commands. Fx is equal to mx plus c, fit fx data.txt via mc, plot data.txt plot data.txt with point size 4 with line color red, title observed, comma slash fx with line width 2, line color black, title title is theoretical. Title is theoretical, and we set X label as X and set Y label as Y and save it. Save the data, then go. So we have the commands over here, and here is, so we have the commands over here, and now we want to just compile and run in the terminal. Let's see what results it brings. Just open GNU plot and load plot.txt and just hit enter. We have a straight line fit, x label at the x-axis, y label at the y-axis. The observed values are in black star, and the theoretical value, best fitted value, is given in the red line. Now we can just change it. This black we can change to something like green, and this is red to something like black. Just see the results. Yeah, in this way we can just best fit our given data, and to bring the grid lines we can select the grid lines. Now to save it, we can save it in PDF, SVG, image format, etc. Let's save to image format. Just export it to image and just write name like plot1 and just save it. Now let's see our result. Let's see our result. It is in fit. We have a file named plot1 of our best fitted data. This is how we can best fit our given data in one way. We just see the files, what is inside this folder named best1. Here is a file named z for linear.f95. Gedit linear.f95. Here we have a Fortran file. Now here in this program named linear, we have the data. There are 8 data for x and for y. Here Sx is sum of x, sum of y, sum of xy, sum of x square, and the deviations, mean, intercept, and other calculations are done. What we do is, here we just make necessary calculations and just save in designated files. Here we have opened 5 and closed 5. Similarly, we have opened 3 and closed 3 over here. Now save the program, and what we do is just go to the terminal and Fortran linear dot f95 and dot slash a dot out. Let's check the folder. Here our data, our calculations are executed in the folder assigned. Here we have a file named linear.txt where we have the data, the necessary data, and in calc.txt it reads the sum of x is 56, sum of xy is 364, sum of x square is 524, and sum of y is 40. The slope is 0.636, and similarly the intercept is 0.545. So we have received the following calculations. Now GNU plot. Enter the GNU plot. Now we make a file. We make a file plot dot txt and we type in the command as given here. Here set on png Cairo gives the output in png format, linear.png, and we can just change the size is linear.txt with point thickness 4, line width 3, and x level is set as x and y level is set as y, and finally we onset the output. Just save it and go to terminal, load GNU plot and load plot.txt. Just press enter. In the folder named best one we must have a nice image. Here we have the image of the graph. Now we can just make necessary changes. The line color blue and red. Observed. PDF Cairo, and similarly change this as PDF. Just save it and just load the data and see the outputs. Here we have a PDF output of the given data. Here in the X label we have values of X, values of Y, and the theoretical values are in red, straight line fit, and the points are in blue. Again, make the necessary changes. Point thickness is 4 over here. Let's change it as 2 and see how what's gonna be there. And just reload this. Yeah, just we have just come up with some changes. This is how we can just make the plots straight line fit of the data. Here we wrote the code, Fortran code, and we got this linear.txt and calc.txt, and using this data we just made a code file in txt format and pdf caro or png caro, and we just exported the results. Now exit the edit exam.odt and exam. This is the odt file. We are saving the odt file. We can edit in the text editor finally. Just the odt file. Just open in the text editor and we can type in the codes, input the data, copy these codes and paste it. Then we get the following results. What we get: linear.txt and plot.txt. .txt and similarly we get plot.txt next file. Now where it is? Oh, we got calc.txt. We got calc.txt and we finally make a text file calc.txt. We finally make text. Sorry, we make a text file plot.txt where it is. Then we go to terminal, open GNU plot and load plot.txt. Get a nice output in PDF format. For PNG, what we do is we change the file extension to PNG Cairo and .png codes. So PNG, PNG. Just save it and Unicode. Load plot.txt. Yeah, we got a nice PNG file, and then what we can do is we can insert the image. Just search where is the image, and this is our image. Just open it, and we can just make the necessary adjustments. Here, program codes, then the following results. Then what we do is we can save this as ODT. Similarly, we can export it as PDF. Exam. Yes. Now just check it. We've exported our results, the question answer, the codes, the results, and finally the nice graph of our results that can be submitted in the exam. This is how we can just best fit line, best fit our data using Fortran codes. Thank you for watching.